So we're going to continue our lesson on topic 2.1. So these next two problems actually come out of Delta Math, which is more going to be what your homework looks like tonight. We're going to be using the line segment to find the average rate of change, which you'll notice that sometimes we abbreviate average rate of change AROC, average rate of change, on the interval from 2 to 5. So the first thing they're going to actually ask you to do is they're going to actually ask you to look at the graph, and they're going to actually ask you to go to the 2, and then you're going to have to plot that. You grab that, and then you're going to have to touch here at the 5, and then it will automatically draw that line for you. Then you're going to use the line segment to actually find that rate of change. And when they're talking, this means change in y, and this means change in x. So basically, I've got to count my change in my y over my change in my x, which is going to find me the average rate of change. So, or just, which is also equivalent to the slope. So I'm going to count the slope in this graph. I'm going to zoom in so I can see a little bit better. Or not, it's super blurry, isn't it? We notice that the y-axis is scaled in 2s, but the x-axis is scaled in 1s. So be careful. I noticed that in the Delta Math system that they're doing their scaling weird. So make sure you watch for that. So I'm starting kind of where I'm looking at this slope triangle here. It's probably easier to just kind of try to envision or draw the slope triangle. So I'm going to go 2, 4, 6, 8, 10, 12. So I know that that's 12. And then I'm going to count this way, but remember this way is only in ones. 1, 2, 3. So it looks like that average rate of change, or that slope, is equal to 4. In this next one, this is as close as they got to what we were doing in example 1 and 2 in Delta Math. And I couldn't find any great homework that was like example 1 and 2. But again, it will build to tomorrow. So for the function f of x equals x squared minus 1, find the slope of the secant line between these 2 points. So really what we are doing to find the slope of a secant line is we're going to evaluate the 2 points for the function. So that would get us our y value. So we're going to do f of 2 minus f of negative 5 over 2 minus negative 5. So the double negative is going to go positive. All right, so we're going to go ahead and plug this 2 into this function. So that means I've got 2 squared minus 1. And then I'm going to subtract, and I'm going to plug the negative 5 into that function. So negative 5 squared minus 1 over 7. Might as well do the arithmetic. And then 2 squared is 4. And then minus the negative 5 squared would be 25 over the 7. And then 4 minus 1 is 3. 25 minus 1 is 24 over 7, which equals negative 21 over 7, which is going to be negative 3, would be the slope of the secant line.